How many people have heard of Bedmas? Did you do that last year in your class? So, Bedmas helps us remember our order of operations. So I'll give you a minute to write this down. Let me know when you got the first couple down, then I can move it. Can I move it down this to there now? Okay. Did you know that adding and subtracting could actually be switched? You could do the subtracting first if you wanted and adding second. But I think they decided on this. This is an easier word or thing to say, right? Can you imagine if they switched the A and the S? It's harder to say. Be harder to remember your order of operations if you had to remember Bedmas. But it would work. I've heard in some places they don't use brackets. They use parentheses. And they learn Bedmas instead of Bedmas. You learn Bedmas, so you have parentheses? You too? Yes. So, if you wanted brackets or parentheses, Bedmas, Bedmas, they both work. Okay? I don't know if there's anything else. You could like switch it up. Like you could change multiplying to like.
Hi, sorry to interrupt.
Hello.
Did Rawson make?
I mean, if you called multiplication timesing, which is not as good of a word, right? Then you could have like bedtas. And subtracting, if you called it minusing, you could have like, bed tam. I'm sorry, if we keep messing this up. We'll stick with Bedmas. And for those of you that learned Bedmas, you just have to, I hope you can handle brackets this year. Should be okay. But this is an order of operations. It tells us when we do multiple things in math, we have to decide on the order we do them, because if we don't decide on the order, we could get different numbers. So for example, 2 plus 3 times 3. If one person adds first, right? One person adds first, one person multiplies first. Okay? According to Bedmas, we should multiply before we add. So according to Bedmas, we should first do the 3 times 3, which would give us 2 plus 9, and we get an answer of 11. But if someone didn't know Bedmas, they might just go, well, if I'm doing things, I'm going to do things from left to right, because that's how I read a book. Right? So 2 plus 3 is 5. Then I get 5 times 3, and then I get 15. And so this causes a problem, because if we want to communicate things to each other, we want you to get the answer I want you to get, rather than getting an answer that's different. Right? Can you imagine if people did this with writing? Like, had a new order. Like, in writing and reading, you always go from left to right. But if you wanted to write, I am in grade 9, right? My new rule is skip every other word. And then go back to the beginning, and then go backwards. So, I am in grade 9. Perfect. This is how we should write from now on. Can you imagine how your English teacher would feel after that? Every sentence, you just skipped words, and you got to the end, then you went backwards and skipped back until you got to the beginning, and that's how you'd have to read? Oh, it would take a lot longer to read. It could be a rule, not a very good rule, but the idea is we have rules for things. Reading, you just read left to right, unless, right, some languages don't read left to right. Have you ever come across a language that doesn't read left to right? What language? Arabic? Japanese? Goes from right to left. You start at the back of the book. Sometimes a graphic novel, you start at the back of the book and work your way to the front of the book. It's just different, but they have a different rule. So in math, what we decided is we're going to have an order of operations. If we want to make sure you do something first, we'll put it in brackets. Exponents, we'll do those right away next. Then division and multiplying, addition, and subtraction. So that there's not confusion between should this be 11 or should this be 15. Okay? If we wanted this to be 15, we'd have to say, oh, I wanted it to be 15. I'll put brackets around the 2 plus 3. So you do that first. And then you would get 5 times 3 and get 15. So order of operations can be confusing because we can get a bunch of stuff, and if you mess up one of the orders, you'll get a totally different answer. Does that mean that you're bad at math? No. It just means you've messed up one of the order of things, and it's very easy to do. So let's look at some examples. Use the order of operations for the following questions. One of the things you might do on your quizzes and tests or even on your homework assignments is write Bedmas off to the side just to help you remind and go through it from left to right. Do we have any brackets? Yeah, we do. So let's do those first. What is 3 minus 6? Negative 3. Yeah. Think about your number line again. And again, think about your number line just in your head. If I start at 3 and go back 6, I'm going to get to negative 3. I would still have then plus 2 squared. And I'm just going to do one thing at a time. Sometimes as you get better to this, you could have been like, ooh, I could do the bracket and the exponent at the same time and feel like everything would be good. So you might find you can find some shortcuts. That's great. Shortcuts make things faster. Shortcuts also increase your chance of making a little mistake. So now, we no longer have brackets. Perfect. Do we have an exponent? That's the little number. Yes, we do. What does 2 squared mean? 2 times 2. The little number says multiply this number by itself that many times. So off to the side here, 2 squared means take the 2 and multiply it 2 times. 2 cubed means take the 2 and multiply it by itself 3 times. So 2 cubed is not 6, because 2 times 2 is 4, times 2 again becomes 8. So we can now go negative 3 plus 4. And we've done our exponent. Do we have any dividing? No. Any multiplying? No. Do we have adding? Yes. Negative 3 plus 4 is, think about your number line, If I started at -3, went 4 to the right, I'd get to +1. One of the things you can do when you're showing your work is write an equal sign all the way through to say this is equal to this, is equal to this, is equal to this. And when we're doing our work in math, we often like to write things vertically. One of the things, if you are super environmentally friendly, or how much does it cost now to buy all your loose leaf? You get like, don't they usually have it on like a crazy sale? Like 10 cents for the whole thing, or 20 cents sometimes? Okay, so it's pretty cheap to buy paper. But if you want to save paper, a lot of the math that we do like this, one thing after another after another. So if you look at your page, do you notice like on the right-hand side of your notes, you have like nothing written? If you want to save paper, I've seen people take their piece of paper, fold it in half, and do their notes. Here's September 11th, my notes, work, math, work, and then when they get to the bottom here, instead of having to flip the page over, they just go to the other half and keep working, because you'll have often enough space to do that. So if you wanted to save paper, you can, okay? Because I think it's really important to write your math one step under another, because then it's really easy to see, oh, when I went from this line to this line, what changed? This is the only thing that changed. And I can check, is 3 minus 6 negative 3? Yes. Then from this line to this line, the negative 3 didn't change. Oh, but, oh, purple. This changed. So I can see easier what's changing, and it's a little bit easier to see, am I making a mistake along the way? Sometimes in math, like when you get a quiz or a test, sometimes a question's worth 2 marks. Okay? In this question, if it was worth 2 marks, you would get 2 out of 2 because we got it right. Yes. Okay? We showed our work, and it's easy to see, oh, this is what I did first, this is what I did next, everything is right. Okay? Now, I think I heard someone say this, so I'm going to do, don't copy this down. Okay? I'm going to make some mistakes. Okay, we'll do it in red because sometimes you get X's in red. This is a mistake. Don't copy this down. 3 minus 6, 3 plus 2 squared equals 3 plus 4 equals 7. That's not the right answer because we already know the answer was 1. But because I showed my work, where was our mistake? I think someone even said that at the beginning. When we had 3 minus 6, somebody said 3. It's an easy mistake to make, right? If I see your work like this, I'm like, oh, you made the easy mistake, but did you get the 2 squared right? Did you do the order right? Our order was right. Our 2 squared was right. We made a small mistake with adding and subtracting integers. As a result, you would get 1.5 out of 2. Because you showed your work, and I can see that most of the stuff you're doing is right, just one little mistake in the end. Okay? As opposed to this. This person might have done exactly the same thing that we just showed, but they showed no work. I don't know what they're doing. This would get 0 out of 2. No work is shown, and I can't guess, saying, oh, I think they know what they're doing. I have to say, I looked at your work, and I can't tell, because all you wrote was your final answer. Okay. Sorry. Choom, choom. Second example. Off to the side, I write Bedmas. First letter is a B. Do we have brackets? Yes. Okay. Do we have anything to do in the brackets? No. So I'm going to write a note. Can you tell that that says negative even though I ran out of space? Okay. No? I should rewrite it? Okay. Is that better? Sometimes a negative number sometimes a negative number is put in brackets just so you know that that number is negative and it's together. But there is no math to do in the brackets. This is an example of that. We have a negative number 4, it's in a bracket, but we don't have any math to do inside that bracket. So then you're going to be done without doing anything. We're done brackets. Even positive numbers are sometimes put in brackets. Remember at the beginning I had said, do it up to the side here. That's another way of showing multiplication. I have brackets. My order of operations says do brackets first. But when I look in those brackets, I just have a single number. There's no math to do inside the brackets. So then the B part of Bedmas is done. You could just say, oh, this is multiplication. It's 21. Done. So that's the case here. We've got brackets. We look, okay, nothing to do there. Next, do we have exponents? No. Do we have dividing? No. Do we have multiplication? Yes. So my first step underneath here, put my equal sign. 5 times 3, 15. Got a plus sign that would stay there. Negative 4 times 8. Is it going to be positive or negative? Negative. Right? A negative times a positive. It's going to be negative. And then what is 4 times 8? 32. So it's going to be negative 32. And you will see some math teachers go, hey, I like to keep my negative numbers in brackets. So you might see some people put that in a bracket just to hold it. Sometimes it gets confusing if you have a positive and a negative right beside each other. If you leave it without the brackets, I'm going to be okay with that. But you'll often see more of this where they put that number in brackets. Right? Going through our order of operations, we just did all the multiplication. Next we have adding, and here we're adding a negative. Adding normally went to the right, but the negative would make it the opposite, go to the left. Sometimes you'll even have students who decide, I'm going to rewrite this without the brackets and just go, it's subtracting. Adding a negative is subtracting. Okay? 17. But if I'm at 15 to start, I go back 32. I'll end up at negative 17. Now, depending on the calculator you have, I have a very fancy one on here. I'll show you what my calculator looks like. If you bought the calculator through the school, it will do this as well. So what was our question? Our question was 5 times 3 plus negative 4 times 8. The nice thing about new calculators is you can go 5 times 3 plus negative 4 times 8. If you write it exactly as we had, oh, ours even had brackets. I'm going to put that negative. That's exactly what our question said. 5 times 3 better, eh? Now you can see it even better. That's exactly what our question said. If you have a good calculator, you can type exactly what you see, and when you hit enter, negative 17, boom, tells you the right thing. Really good for all high school math. Because on a lot of your quizzes, even order of operation quizzes, you will have your calculator. So you can check by writing exactly what you see into your calculator, pushing enter, and you can find out, did I get my answer right? Is it negative 17? Yes. It's the same. You can do that during a quiz. If you check an answer with your calculator and it's right, and you want to go, yes, it's fine. They used to have exams in the gym. 200 people writing different exams. I told my math class, if you get something right and you want to go, yes, nobody ever did. Because it's like super quiet in there, because there's like, you're in grade 9 and you're writing right beside someone in grade 12. You're not going to be like jumping up and down when you get a question right. You're like, whew. Oh my goodness, this looks crazy. Okay. So you see a crazy question. You take a deep breath, you write Bedmas off to the side. Take it one step at a time. It's not going to be that bad. Do we have brackets? Yes. In fact, can you see we have square brackets and round brackets? We have like 2 sets of brackets. So find the smallest brackets that you can and do those ones first. Can you see the 7 minus 2 is inside these brackets? Is there math to do there? Yes. What's 7 minus 2? 5. So rewrite everything equals, keep that square bracket, 3 plus 7 minus 2, 5. The only thing I changed, I'll underline it in green, is I did that brackets to become 5. Do I still have brackets? Yes. Is there math to do in those square brackets? Yes. So then I write equals 32 divided. What is 3 plus 5? 8. Okay. Do we have any more brackets? No. So then we go through Bedmas. Do we have exponents? No. Do we have dividing? Yes. 32 divided by 8 is 4. I mean, we could keep going now. Okay, now that we have 4, do we have multiplying? No. Do we have adding? No. Do we have subtracting? No. We're done. Now, most people realize when they get 4 that they're done, because you've just got a single number. But if you wanted to, you could go through all the steps to find out for sure that you are done this question. 2 more examples, and then I'll give you some to practice. Oh, this one, it doesn't look nearly as bad as that last one with 2 brackets. Do we have brackets? Yes. Is there math to do inside of those brackets? Yes. Okay, then let's do it. We have 24 divided by 6 plus, what is 9 minus 5? 4. All right. Do we have any more brackets? No. Do we have exponents? No. Do we have dividing? Yes. What is 24 divided by 6? 4. All right. Do we have multiply? No. Do we have adding? I mean, when you get down to the last one, it's sort of like, we only have one thing. I'm pretty sure that's what we have to do next. 4 plus 4, 8. Bedmas. Do we have brackets? Yes. Do we have math to do inside of those brackets? Not this time, right? Because we're just holding the -2, just holding the -7. Okay? So our brackets, even though there is brackets, it's just holding numbers. There's no math to do inside of there. We're done. Exponents? No. Dividing? Yes. 54 divided by 6 is 9. So we write equals 9 plus, and then everything else is still there. What's happening here? Multiplication. So that's after dividing. We would do that next. 9 plus, well, I'm going to put a little green dot here, because that means 4 times -2. Because all those numbers, those 3 numbers there, are all multiplication. And we also have 2 brackets beside each other. That means multiplication. So that means that that -2 gets multiplied by that -7. Okay? So 4 times -2 will be positive or negative? Negative. So I'm going to put it in brackets just to hold the negative with it. And then I've done these two. I still have another multiplying. 8 times 7, 56. -8 times -7, will it be positive or negative? Positive. And then finally, 9 plus 56, 65. Perfect.